Good afternoon, everybody. Welcome to the webinar by Spot On Networks. For those of you in the East Coast and the Midwest, good afternoon. For those of you in Mountain and Pacific times, good morning. Today we are going to discuss an extension of previous webinars, the future of in-building voice and what's been happening and what's going to happen. A little bit about us. We've been around since 2005, so for the last 9 years or so, we've become a pretty trusted name in the multifamily residential community segment for the provision of managed Wi-Fi and other in-building wireless services. We currently operate approximately 800 networks around the country. We support various wireless functions, primarily user-safe Wi-Fi, and we also provide a cell booster system called CellBoost 1 and CellBoost 2, and we've added some applications onto our wireless networks to provide such things as energy management, patient tracking, surveillance, and other functions that make use of the IEEE 802.11 protocol to provide various wireless monitoring functions. Our three major products are user-safe Wi-Fi, which is Wi-Fi in a multi-tenant building, secure and safe, CellBoost, both versions 1.0 and 2.0, which provide both signal booster and hybrid DAS systems for multifamily residential buildings, and Wi-Fi Plus, which is the wireless backbone and bolt-on applications. Just for some administration function, I just want to indicate to you what we're going to be doing. First of all, you will primarily be muted. All of you will be muted. Questions that you may have, and there may be quite a few based upon our last webinar, please submit them into the chat bar. We'll do the best we can to answer them before the end of the hour. At the end of this webinar, we'll be giving away a 40-inch Vizio Wi-Fi enabled smart TV. If you stick around till the end, you are eligible. And if you wish, you can request an emailed recording and the links to view this webinar on our YouTube channel. To give you an idea of who's presenting today, Tom Doyle is our President and Chief Operating Officer. As you will see on the screen, he comes with a diverse background of wireless telecommunications. He had spent 5 years at Motorola as Director of the Integrated Solutions Division, and he was responsible for the New York State Public Safety Organization within Motorola. I have been involved in wireless for too many years to count. I've served as a CEO of Metromedia International Telecommunications, and I've run cellular telephone operations and wireless cable television operations in Eastern Europe. Let's talk for a minute about what we are going to be talking about today. There have been many changes in the cellular industry, especially in the last 6 months. As you probably had read in the Wall Street Journal this morning, both AT&T and Verizon are being pursued for overcharging because of the way they handle unlimited data. The very fact that they have created unlimited data packages and then taken them away and then put them back again and compete against other carriers like Sprint and T-Mobile that have unlimited data packages is kind of an indication of how fast things change within the business. We are going to specifically focus in this webinar on voice solutions. We'll include data, but voice solutions is the key issue, and we'll explain why as we go through this, and what the cost is to implement voice solutions within a multiple dwelling unit building. We are concerned about two things, what we call the 2 C's, coverage and capacity. Many of our building owner clients have indicated how important both coverage and capacity is within a building, especially LEED certified building where construction materials prevent the penetration of radio frequency into the building. We are going to briefly touch upon heterogeneous network solutions, where we combine multiple solutions into a building so that we satisfy the building resident requirements at a low cost. We'll talk about some of the parameters that are necessary to make sure voice works, and we're going to indicate to some of our building owner clients, they've asked us the question, how do we monetize this Wi-Fi calling situation? Next chart. In our last webinar, which was held about 60 days ago, we talked about the fact that Wi-Fi calling had recently been announced and by Apple specifically, and that T-Mobile had supported it immediately, Sprint supported it a few days later. And we speculated that that market demand would cause both AT&T and Verizon, which are the two major carriers, to support Wi-Fi calling. Within a few weeks after that discussion and that announcement from Apple, both AT&T and Verizon announced that they would both be supporting Wi-Fi calling. Let's talk about the event timeline that we have seen in the last few months. As I mentioned, Apple announced at its Worldwide Developers Conference that the iOS 8 update would include support for Wi-Fi calling, and we'll discuss the detail of that in a minute. Subsequent to that announcement, within a few days, T-Mobile announced it would be the first carrier to support Wi-Fi calling on the iPhone, native dialing on the iPhone. Sprint, within a week later, announced the same thing, and then 2 months later, AT&T announced that it would support Wi-Fi calling in the first quarter of 2015. A week later, again in September, Verizon announced that it would support Wi-Fi calling by the summer of 2015. As a result, all four major carriers will support some form of Wi-Fi calling by the middle of 2015. Let's talk about the problem, not of your making, that faces today's building owners. First of all, the current demographic of the apartment residents are what we call millennials and Gen Ys. They use smartphones almost exclusively for all their primary communications. That's for both voice and data. In fact, AT&T pointed out that barely 17% of multiple dwelling unit residents in their territory subscribe to landline phone. However, one of the problems is that in many high-rises and mid-rises, wraps, and garden style made out of concrete, there is extremely poor mobile coverage because of the construction materials. That results in complaints, lost renters, tenant issues, and maybe lost revenue. It also results in no 911 service being able to be used by the residents. To combat this problem, many building owners have put in DAS systems, distributed antenna systems. They are extremely expensive. They take a very long time to implement, and the building owner is under complete control of the carriers. In fact, just last week, AT&T told the major building owner that they will no longer connect to distributed antenna systems during 2015, and the building owner would have to wait until 2016. That's a major issue for building owners with distributed antenna systems. Let's talk about what the available solutions are to solve the voice coverage issue inside these kinds of buildings. We've mentioned these before, but I want to delve into them a bit. There are solutions that require carrier approval, and those include the distributed antenna system, which is an antenna system backed by a fiber-based solution, turning a building into an entire cell site with coverage antennas throughout the building. There is a solution called small cell. It is implemented generally by a carrier. The carrier must not only design the network, but actually install it. While it's less expensive than a distributed antenna system, it is a single carrier solution. The third alternative in this category, those that require carrier approval, is CellBoost 2.0. We call this, it's a hybrid distributed antenna system. Basically, it is a distributed antenna system inside a building that utilizes a donor antenna on the rooftop of a building and relies on the cellular signal being present outside the building. It allows for a signal adjustment by the carriers so that they will approve such a design. And again, as I mentioned, it does require an approval. The next two solutions do not require carrier approval. CellBoost 1.0, which is about a fifth the price of a distributed antenna system, uses a similar technique to CellBoost 2.0, the hybrid does, in that it uses donor antennas to bring in signal. However, it only requires registration with the carriers. It is a carrier-neutral solution. All carriers are involved, but it only requires that the network be registered with each of the carriers. The last solution in this grouping is Wi-Fi calling, which we're going to discuss today in some depth. This requires no carrier approval, no carrier permission. It's quick and inexpensive to deploy, and it works with carrier-coordinated Wi-Fi calling and over-the-top applications. As we mentioned earlier, AT&T and Verizon have indicated they are going to support this function by the summer of 2015. By deploying these various solutions together in either one or two of the solutions within a building, we effectively provide heterogeneous networks. That is, we can utilize these solutions in a mix and match combination in order to provide a solution that works for the building. Let's talk about the cost. We're probably a little conservative on this, but the key point is that the distributed antenna system runs around $2 to $2.50 a square foot. We've seen higher. The small cell runs about half that. Our CellBoost 2.0 runs about 75 cents a square foot. Our CellBoost 1.0 runs about 55 or 60 cents a square foot, and Wi-Fi runs 40 cents per square foot and below. Let's talk about Wi-Fi calling. We mentioned the cost. Wi-Fi calling is nothing more than native dialing on the smartphone. With the announcement by Apple and implementation of Wi-Fi calling, there is a capability on the smartphone, on the Apple, and it already exists on Android, in which by selecting certain parameters when setting up the phone, it doesn't matter whether you're on the cell carrier network or you're on the Wi-Fi network, you effectively dial a phone number, and you're put through, and it doesn't matter to you, to the resident, which network he's on. The smartphone selects the network. And the same thing holds true with incoming calls. With incoming calls, the phone number is searched, and if it's on the Wi-Fi network, it will deliver the call via Wi-Fi. If it's on, if the phone is on the cell carrier network, it'll deliver the phone call via the cell carrier. One of the major reasons why Wi-Fi is so efficient is it is a small cell architecture with substantial capacity. In each building, Wi-Fi can make use of up to 650 megahertz of spectrum. The major carriers have somewhere between 100 and 125 megahertz of spectrum each for the size of the city. The major carriers build their networks to cover wide geography. They use large macro cells to cover broad areas. While this works for suburban and rural areas, It does not work for high-density urban environments. The carriers are now focusing a majority of their dollars on improving capacity in very high-density areas, such as stadiums and large commercial office complexes. But providing in-building coverage to residential buildings is a lower priority because the carriers don't get enough revenue out of that situation. We've talked briefly about coverage and capacity. Managed Wi-Fi gives both of the two C's, coverage and capacity. Because of the vast spectrum available within a building, the capacity is great. It affords large amounts of capacity per user. And coverage can be implemented quite easily within a building because it is relatively inexpensive to add access points in specific areas. Managed Wi-Fi currently provides seamless voice coverage for both T-Mobile and Sprint users in apartments. And it does so as well in corridors and amenity areas, meaning that if I am walking around from an apartment unit to a corridor, I basically have the ability to carry on a conversation as if I were on the cell system, even though I'm on Wi-Fi. Wi-Fi offers residents and tenants unlimited data offload at very high speeds. We have put in place networks that provide as much as 30 and 40 megabit per second service to each user. And users are capable of streaming multiple video streams at the same time on different devices. We've architected our networks to provide a secure, reliable, and complete in-building coverage. Okay. What we have learned about buildings is that they're all different. The topography, the construction material, and the layout all provide differences from building to building. One solution does not fit all buildings. There is no such thing as plug and play, and that quote is directly from Paula Dublin, who is the at&t AVP for Antenna Solutions, who spoke just a few weeks ago at the 2014 HeadNet Expo. You can't just put a system in and expect it to plug and play, as the cell carriers did when they first began cellular coverage. They effectively put up their cell networks, and they expected everybody to get service. Doesn't that work that way in a building? Each building's network solution needs to be architected specifically for that building, which includes a coordinated frequency plan that not only pinpoints areas of poor coverage by carrier, but also establishes a remediation of interference issues. We've recommended to many of our clients an exhaustive site survey that does two things. It determines wireless coverage challenges in the building, where the problems are in the building, and it also determines what kind of design is needed, including a cable pre-design to future-proof the building. By providing a patent-pending network technology that provides optimal coverage with no signal loss, we've established a very high level of service within a building. By deploying multiple solutions, as I mentioned earlier, we call this heterogeneous networks, we have the ability to handle different problems within a building when they crop up. And you see on your screen an example. A site survey may determine that a building has acceptable service from a couple of carriers and unacceptable service from other carriers. What we've done is we've recommended a single carrier small cell together with Wi-Fi network to solve the problem. Now what I'd like to do is hand over the presentation to Tom to talk about some of the details of the managed network function.
Thank you, Richard. I wanted to get into some of the differences, frankly, between voice and data without getting into the technical weeds too much here. But if you're a building owner, you might be out there saying, great, Wi-Fi now supports native Wi-Fi calling. I've got a problem in my building. I don't need to do anything. And unfortunately, you'd be wrong. So a couple reasons for that. The primary one, frankly, is that voice is not data. And that means you need some parameters on your network to make the service work better and have a quality experience for your residents. So one of the first things we're always up against is why not let residents use their own Wi-Fi routers for voice coverage if Wi-Fi calling is now the supported protocol by all the carriers. And it's a bad reason for a couple reasons. We've got them listed here. First of all, most consumer routers have no what's called quality of service on them and no coordinated frequency plan, resulting in poor, unreliable voice service due to interference. So as you know as a building owner, the solution that works in a single-family house, everybody gets their own router, is not the solution that's going to work in an apartment building. When you've got an apartment building with 300 units and you've got 180 Wi-Fi routers, you're going to have channel problems, you're going to have interference, and you're going to have congestion. So you need a managed network to kind of provide a quality experience. The other issue is the personal routers do not provide property-wide coverage. So if you're going to solve the voice problem at your property, it needs to be holistic. It needs to cover the hallways. It needs to cover the stairwells. It needs to cover the pool areas. And you're only going to get that with a managed service throughout the whole property. You're not going to get that with each individual person having their own router. The other part about that is you need a managed network, so you've got a holistic 911 service at the property. As Dick mentioned, AT&T and Verizon have announced support for Wi-Fi calling in 2015. Unsure exactly how that's going to roll out, and we'll get to why we think there's some interim solutions for you. But until that's rolled out, it's good to understand that both T-Mobile and Verizon, T-Mobile and Sprint at this point have different ways to configure 911 on their phones, and they handle it a bit differently. But if you're going to get a 911 service throughout the whole property, you need a managed network throughout the whole property. The other thing that you may have seen a lot about is the whole dual SSID approach. I'm going to get to that in the next slide. But minimally, the whole dual SSID approach in MDUs causes congestion and can impede voice service. And as we mentioned, we need to make a distinction between voice and data. If you've got a data network that's got some latency and some jitter, you can still have a quality experience. For those of you who've used Netflix and seen things like buffering, that's okay if you're watching a movie and want to wait for 5 or 10 seconds as it buffers. It's not okay when you're trying to have a voice conversation because it's not usable at that point. That's why voice is fundamentally different from data and why you need a managed service at your property. So the other thing that we want to talk about later is a little bit is the revenue opportunity for this. But essentially, you've got some potential cost savings. You've got revenue opportunities. As we mentioned, as Dick mentioned before, this presentation is primarily about voice services. The beauty, obviously, of Wi-Fi is that there's a whole host of data things you can do also. And we'll talk about those in another slide. So the dual SSID approach, again, from our perspective, is tragically flawed. And I don't think I'm understating that. And it's even more so in an MDU environment. You're essentially taking, excuse me, for those of you who don't know how this works, if you're a Comcast or a Cablevision customer, and they ship you a Wi-Fi router, that Wi-Fi router will have one SSID for you to connect to, and it will have a separate public SSID like Xfinity or Optimum Wi-Fi, for example. And so on each home router, you've got two SSIDs. So essentially, it's a way for the cable companies to kind of avoid doing the hard work of putting in holistic managed networks in a building. Their approach is ship the person a router. The router will have both its own SSID and a public SSID that you can work with. And so anybody who's a general public kind of person in that area can connect to that separate SSID. So that's the way they're handling not only public hotspots, but home routers. And there was an article actually last week in Light Reading that was very specific about, even from the Comcast perspective, about the the problems that can have in an MDU environment. So what they actually said is that the use of dual SSIDs is even more detrimental in MDU, where multiple routers with both personal and public SSIDs can create network congestion on what is still a shared spectrum experience. Network congestion and lack of QoS, which is a major issue with individual routers in the MDU space, kill the voice experience. And the quote from Charlie Douglas, who's the executive director of corporate communications at Comcast, basically was that home hotspots could experience network congestion from guest users. And I guess the easiest example to think of is if you're a Comcast customer, for example, and you've got your home router with a dual SSID, one of your kind of neighbors' friends comes over, log into that Xfinity SSID to stream a video. You now try to connect to that SSID to make a voice call, you're going to have a problem. You're going to have a problem because the bandwidth is shared and there's interference issues. So from our perspective, this whole notion of dual SSIDs is a bad idea for the MDU space and is simply a shortcut that the cable folks have implemented to expand their footprint. The other thing we've talked about in a number of different webinars that we've done is our view is that Wi-Fi is the vehicle for both voice and data going forward. And the beauty of putting in a Wi-Fi calling network in a building to solve the voice problem is you get all kinds of ancillary benefits that accrue to not only your residents, but also you as an owner, your staff. You can do, obviously, the whole offloading of data onto Wi-Fi networks where you're not paying for cellular data, and their rate plans that are now limiting us to 4, 6 gigabytes. So you've got that facility. You've got the facility of your staff to be able to kind of use tablets and network netbooks and other types of laptops to kind of run applications. You've got IP-enabled energy management applications and building automation. So there's a whole litany of things you can do now with this network you put in place to solve the voice problem. So some of the parameters we talked about previously and why they're important for a voice network in a building. Clearly, as we said, it needs to be managed. The whole everybody doing their own router stuff is not going to work. It's not going to be a holistic network. There's going to be interference issues. There's going to be problems, and those problems will become severe when you're trying to make phone calls. You obviously need a network that's secure from hacking and spoofing and the types of malicious stuff that goes on these days. QoS is a very important parameter. We can, without getting, again, too techy and what happens when the packets leave the building, at the end of the day, if you've got a managed network in a building, you need to have QoS on the LAN side of the network for things to work right. And you need bandwidth constraints, and you need, obviously, coverage and reliability. The other big issue we're going to see a lot more of in the next 2 years here, as 802.11ac starts to proliferate, you're going to get wider channels from all of these Wi-Fi routers. Wider channels have the benefit of allowing us to get more data over a network. Unfortunately, they start to create the possibility of more interference. So if everybody's got an 802.11ac router in an apartment building, you're going to start to have all types of interference issues and performance issues from too many routers in one space, if you will. The other thing you need, we've talked about this previously, is the network needs to be CALIA compliant. It needs to be able to handle the E911 requirements, and clearly you need someone on the back end taking care of this. In terms of the CALIA and the 911, we've talked about CALIA before. For those of you who've been on other webinars, essentially if you put a network into a building, whether it's voice or data, and you are a de facto ISP, you subject yourself to potential CALIA requests, which are requests for information from a local jurisdiction around providing IP information and other information about people doing potentially malicious things on your network. The other part of it is the 911 services. Again, it's a little unclear how Verizon and at&t are going to support Wi-Fi calling and how they will handle 911, but the there's a lot of impetus and push in the 911 space to support things like text-to-voice and other IT-enabled ways to do 911. So a managed network across the whole facility is probably the best bet in terms of handling 911 functionality. The solutions we put in are both obviously fully managed and CALIA compliant. So for us, it's frankly an exciting time for building owners, and the reason for that is I think for the first time you've got the facility to control your own destiny. Previously, as Dick mentioned, if you had a voice problem in your building, you had a couple alternatives to solve that, some of which are very expensive and are very time-consuming to implement. And you certainly were not in control of your own destiny. You had a problem in a building that you didn't cause, but your residents, frankly, were holding you accountable to solve the problem. So the beauty of unlicensed frequencies and the beauty of Wi-Fi calling is you do control your own destiny. You now will have a way to go put a network into a building that's not going to need carrier approval. It's not going to take 9 months to get approved and implemented. It will allow you to solve that voice problem. And again, without knowing how AT&T and Verizon support it, our view is that the market is going to push them to act as T-Mobile and Sprint have implemented it, and that will be good for all of us, the 90% of us who are out there now with smartphones. So what do you do with this network now? There's a couple of different ways to handle this. There will be building owners who want to treat this purely as an amenity and offer it free to their residents. So anyone with a smartphone who's got a cellular problem can get onto this thing and make a phone call. Clearly, you can build the cost of this thing into the rent. There are various payment mechanisms where you charge for voice and data type services. Most of the people moving into these buildings, most of the Generation Y types, as we've talked about before, they use their smartphone, they've got a tablet, and they've got a laptop computer, and they're all streaming, and they're all accessing the internet. And the reality is, in 5 years from now, and you've already started to see this with HBO developing a paper service over the internet, they're all going to deliver their functionality over the internet. That's where it's going. And having the managed network in your building will deliver these advanced telecommunication services. So the other thing that we've heard about previously is there are building owners who've got contracts with internet providers that have precluded bulk arrangements. Our view is that a Wi-Fi calling network does not violate the contractual provision because you're providing a network. The other part of this is that we have the ability to architect networks that allow you to only offer smartphone access on this Wi-Fi network and have a customer with either a tablet or a laptop access a separate SSID, if you will, with higher speeds and different rate plans. So you can offer a bulk Wi-Fi network for smartphones that you may or may not charge for, but that could be distinct from the access method by either a tablet or a laptop computer. But all of these are can be architected such that you can charge your residents or offer it free of charge. With that, I'm going to turn it back to Dick.
Thanks, Tom. So we have a couple of concluding slides that I think are important. There are two different building types that we have to worry about. One is a new build and a development which is just getting underway from a construction standpoint, and the other is an existing building. We believe that site surveys are critical in both situations. In the new building environment, a site survey should be done immediately upon the erection of the outside walls and the windows. But one of the things that should be done early is determination of the low voltage electric design to see whether or not additional cables can be put in while putting in the regular structured cable pairs to future-proof the building. For an existing building, obviously you're not going to rip down walls and to put new cables in, but a site survey will help identify where the problems are, and maybe what can be done. So we recommend that highly as a first step. One of the issues that Tom has pointed out very clearly is, look, AT&T and Verizon are scheduled to implement Wi-Fi calling between the first quarter and second quarter of 2015. For those of you who are putting in buildings now, what do? What's the right solution? And our view is that CellBoost, which is a fraction of the cost of a data system, is the right answer. If we can implement CellBoost and provide coverage in the interim, while we're waiting for AT&T and Verizon to show up, you will afford your residents the ability to do calling using this technology. So we still believe that Wi-Fi calling is the future, and we believe that once AT&T and Verizon do their thing, Wi-Fi calling will give your residents all the capabilities you need for voice, for data, for 911, and it will provide building owners with a whole bunch of capabilities Tom has mentioned earlier that will really offset some of the costs and give you some tremendous benefits. But because we have to wait, CellBoost is currently the most immediate and cost-effective solution on the market, and we can use it to provide in-building cellular coverage. Now, what's the problem? The problem is we're suggesting that you put in two systems, a CellBoost in the interim and Wi-Fi calling later. To offset the cost difficulties with this, we have decided to make a special offer available until December 31st. Effectively, if you decide to put CellBoost in and you then put in Wi-Fi calling, either at the same time or shortly before the end of the year, we will rebate 30% of the CellBoost system cost to you. If you put in a CellBoost system now and you put in a Wi-Fi network in 2015 or 2016, we'll still rebate a certain portion of the CellBoost system to you. We've determined that to be 20%. So in effect, what we're trying to do is help you with the cost of implementing these networks. Okay, we've reached the end, and we have a whole series of questions, so we will try to address them as quickly as we can. We have about 20 minutes, right? We have plenty of time. Okay. So, the first question, why does CellBoost 1.0 only require registration and not approval? One of the reasons this has occurred is Spot-On Networks went specifically to the Federal Communications Commission and requested a clarification of the report and order that was created in February of 2013 and mandated in 2014, and that was to allow configuration of multiple signal boosters on a single network using a single donor antenna, and that was within, according to the FCC, within the realm of the report and order, followed the certification procedures, and matched the safe harbor statement within the report and order. So as a result, because it's a consumer signal booster network, it does not require carrier approval. It only requires registration. Second question. You have mentioned Passport 2.0 on previous seminars. How does this relate to Wi-Fi calling? So, Passport 2.0 was a protocol established by the Wi-Fi Alliance and the Wireless Broadband Alliance to allow flexibility in roaming, secure roaming, between cell carriers and Wi-Fi operators. Wi-Fi calling effectively eliminates the need for Passport 2.0, although there may be carriers who want to include it as part of their roaming function. Time will tell whether it becomes necessary. However, it can be done, the Wi-Fi calling can be done without Passport 2.0. Next question. I have Wi-Fi calling from Verizon DSL at home on T-Mobile. It's flaky. Is life getting better as other carriers experiment? The answer is yes. The key point is that you really identified the issue. You have a T-Mobile router which is attached to a DSL internet access link. The T-Mobile router may or may not have QoS, but whether it does or doesn't, once the call leaves the router, it's on the internet, and it's operating on a link which is slow, spotty, and as Tom mentioned, is subject to jitter and fade and things like that on the voice.
Well, I think the other thing is, for those of you who've used Skype, right, once you get out on the internet, your packets of data are traversing multiple routers, multiple countries. You've got some potential for latency and jitter. I think clearly the providers of software are doing a better job of handling that kind of activity. The other thing that his question kind of mentioned is Verizon DSL, which might be a little bit of the culprit there also. I mean, I think it's, you know, how this plays out long term is hard to say, but clearly there's going to be, I think, improvements in the routing of voice packets once it leaves the customer premise, if you will, to hit the carrier backbone, right? So right now, a packet's a packet's a packet. Whether or not they implement some kind of, you know, QoS on the WAN side, if you will, that would kind of streamline the packets, I think is the unknown, you know, question we don't have an answer to. But clearly, it's going to get nothing but better. I mean, that's clear.
Next question. If a landlord provides Wi-Fi to all tenants at a property where cell coverage is spotty and the tenants are relying on the owner providing Wi-Fi for calls, does the owner take on a liability if a tenant is unable to call 911? We don't believe that is the case. Just as you have a situation today, if you didn't have any system in place and you had no 911, is it your liability? No, it's not your liability. So by providing a potential solution, you are not taking on the liability of providing 911, you're merely assisting in the provision of the service.
Yeah, I mean, I don't think any of the major carriers, I mean, you know, go check the fine print, right? But none of the major carriers clearly have liability if you're making a cellular call in a parking garage and it gets cut off. There's no, from my perspective,
no liability. Correct.
Liability from the carrier to deliver that call.
I agree with that. Next question. How does voice over LTE affect Wi-Fi calling? It helps it. By having the carrier implement voice over LTE, it makes it that much easier to have complete roaming capability between the cell carrier network and the Wi-Fi network.
I mean, clearly they're going to deliver, I think, some advanced services, you know, a lot of probably video calling over LTE.
And the other thing is that with the voice over LTE, it basically makes the handoff seamless because instead of traversing back to their traditional analog cellular network, it's all remaining digital and over the IP network. So the calling will just get better with the voice over LTE. And AT&T's CEO even said one of the things holding them off from adopting Wi-Fi calling is until they actually have voice over LTE implemented on their network.
Thank you, Thornton. Excellent. Next question. While this, by this I presume you mean Wi-Fi calling, provides incentive for building managers to implement structured Wi-Fi deployments, how is interference mitigated in multi-Wi-Fi network environments?
Multi-Wi-Fi network environments. Well, you know, clearly in an MDU setting, you've got people doing their own things. The issue with Wi-Fi, whether you're at the 2.4 or 5 gig space, is you've got a limited number of channels. You've got a limited number of non-overlapping channels. I think when you're putting in a managed Wi-Fi network, first of all, you're using more sophisticated equipment that can do some channel agility functions and adjust their channels and adjust the power output to provide a better experience to customers. If everybody's got dumb Best Buy consumer Wi-Fi routers, you're not going to have a good experience at all. But if you're on a network that's got more enterprise level, sophisticated antenna technology and firmware, you can start to minimize the interference. But clearly it's a huge issue when companies like Ruckus and Ericsson and people that make Cisco gear at the high end of the spectrum are aware of it, and a fair part of the engineering resources for firmware updates go into interference mitigation techniques. So you've got a lot of IT and smart people trying to solve the problem. But at the end of the day, you do need a managed service. I mean, that's why anybody who's ever played in the public safety frequency space knows you need to coordinate frequencies. And when you've got a shared spectrum and certain channels, they need to be coordinated in the building. So everybody doing the same thing is going to cause problems. And that's why fundamentally MDUs are not single-family houses.
Next, can Wi-Fi calling be implemented in an existing wireless overlay, or does it require a new deployment and new ISP services? I think, go ahead.
You can certainly reconfigure your network to have a separate SSID that supported voice. How sophisticated that network is and what it does and how it peels off voice packets and provides QoS is probably the critical question. But you need network elements like routers, like switches, that can prioritize packets. I mean, the beauty of voice networks is they don't take a lot of bandwidth. So a typical voice call, even at the high end, is 64 kilobits per second. That's a high-level codec for a voice call. You don't need, it's not like streaming video, but it needs no latency, it needs no jitter, it needs QoS on the LAN side to have a good experience.
Next question. How will this, I presume he means Wi-Fi calling, or she, how will this work in hospitals regarding HIPAA? And the answer is Wi-Fi has been implemented in hospitals. Our managed Wi-Fi is HIPAA compliant, and Wi-Fi calling will sit on top of the network, and there won't be a problem.
Okay.
Next. Do you have a future-proofing pre-cabling design solution? Can you recommend a consultant to help design this? The answer to the question is yes and yes.
Did that come from a consultant, by the way?
I don't know. I love this question. Just for the person who asked that question, here is the way we work. There is no single future-proof pre-cabling design solution for each building. It's a building-by-building look, and we'd have to look at the building drawings. And as part of our site survey solution, we will, for a small fee, provide both a site survey and a cabling pre-design if you send us drawings, and we'll do it at a very inexpensive cost. So the answer is yes, we're the company that will help in designing pre-cabling design, and yes, and no, future-proofing pre-cabling has to be done building by building. Next question. How do you keep the user's own in-residence or in-office Wi-Fi from latching onto the cell phone's Wi-Fi calling signal? Will the pass-off to building-managed Wi-Fi still occur? Bergman, would you like to answer this?
So, I mean, it's a tough question. I'm guessing you're talking about roaming between Wi-Fi networks. A lot of that is dependent on the client's preferred network setup, but in other cases, it'll just be a matter of which has the strongest signal. And if Wi-Fi calling is implemented properly by the carriers, then a pass-off to the building-managed Wi-Fi could occur and should be seamless, especially if they walk out of their office and into the managed Wi-Fi for the building.
Okay, Thornton, thank you. I think we don't really have time for any more questions, but we do want to announce the giveaway winner. A bunch of names have been tossed into a hat, and the person who's been selected is
Cheryl Baracco,
Avalon Bay Communities. Terrific. Next. Thank you very much for attending. We hope we've answered the questions. We hope we've given you some information that you can use. And by the way, if you're at National Multi-Housing Council OpTech Conference in Orlando, November 17th through 19th, some of us will definitely be there. Please visit us if you can. Thank you all for attending, and have a good day.